All right, so now we're going to move on to exponents. Okay. So first of all, I want you to think about like addition. Right, so if we have 5 plus 5 plus 5, we get 15. Right, we notice there are 3 5s, right? There's 1, 2, 3. And if you notice 3 times 5 is equal to 15. Right, so if you think about it, like multiplication, is almost like shorthand for addition. Right, so instead of saying 5 plus 5 plus 5, I can just shorten it and say, oh, there's 3 5s. 3 times 5 gives me 15. Right, so it's multiplication is like the shorthand for addition. I should say, well, I should be clear, I should say repeated addition. Right, it's not going to work for 5 plus 3 plus 7 or whatever. It has to be repeated. Okay, and that comes in handy when you know, maybe you have like 10 plus 10 plus 10 plus 10 plus 10 plus 10 plus 10, and you have like a ton of 10s and you don't want to write it all out. You can just count like, oh, there's 7 10s, so 7 times 10 gives me 70. Okay, so exponents are basically shorthand for repeated multiplication. Do it right, Rem. Okay, so just like how multiplication is shorthand for repeated addition, exponents are shorthand for repeated multiplication. So in this example, instead of saying 5 times 5 times 5, that would be 125, I would say 5 to the third power, and that would give me 125. Okay, so here 5 is the base. Okay, that's the base. 3 is the exponent. And then 5 to the third altogether is called a power. So that's why you say 5 to the third power. Right? 5 is the base, 3 is the exponent, 5 to the third is a power. And what the exponent tells you how many times to multiply the base by itself. Okay, right, so if we look here, our exponent is 3. That tells us to multiply the base by itself 3 times. Multiply 5 3 times. 1, 2, 3. Okay, so if we had 7 to the 4th, right, the base is 7. The exponent is 4. Therefore, if you were going to like plug this into a calculator, or well, if your calculator doesn't have like exponents as a feature, then you could just go 7 times 7 times 7 times 7, right? We multiply it by each other 4 times. Right, so now if we have variables, right, our base here now is x, our exponent is 6, so this would be x times x times x times x times x times x, right, 6 times. You can do this with any variable. Base is y, exponent is 3, so we have y times y times y. Some simple word statements, because they'll be used a lot in common, like everyday language. If something is squared, that means it's to the second power. To the second power, or has an exponent of 2. Right, so if you say like 5 squared, then that's equal to 5 to the second power. Okay. You might also hear cubed. right? That's to the third power. And that has an exponent of 3. Right, so maybe you'll see x cubed. That's x to the third power. Right, and that's pretty much the only two like shortened words because they're really common. Squared has to do with like area. If you look at dimensions of a room, like the flooring, you're trying to figure out flooring in a room, it's going to be in a squared, right? So you might be, oh, like the dimensions of this room are, of the floor is 12 by 10 meters squared or something, or feet squared. Right, and then cubed is 3-dimensional. So that would be like if you're finding the volume. So if you're filling up a pool, like a square pool, then it would be the length times the width times the height, and usually volume is measured in like feet cubed or something like that, cubic feet, right? So cubed is like 3-dimensional, squared is 2-dimensional. Yeah, those are the short ones. After that, you just say to the 4th power, to the 5th power. It's there's no shorthand for any of that, right? So that's kind of just really basic exponent definitions. I actually want to do